Perhaps the fourth advanced state is also present, called plasma. Volume of a fixed mass of a gas. Volume ಅಂದ್ರೆ ಏನು ಮಕ್ಕಳ? Volume is inversely proportional to pressure. Delta T is the increase in temperature. Hello students, continuing my discussion on the chapter Thermal Properties of Matter. Today we will enter into the world of gases. The gaseous world is what we are trying to study today. We will understand the nature of a gas, the physical behavior of a gas, and to do that, I will introduce myself to a set of gas laws. Now, before going into the depth of gas laws, you have already studied the states of matter. We told there are three states of matter: the solids, the liquids, and the gaseous state. Perhaps the fourth advanced state is also present, called plasma. What did you learn about a gas? You learned in a gas, the molecules are far away from each other. They are randomly moving inside a conductor. And my kinetic theory says, in a gaseous system, the intermolecular force of attraction, the force of attraction between the molecules of a gas is very minimum. Now, adhering to all this concept, today we discuss something called as gas laws, which will make me understand the physical behavior of a gas. Now, before I could discuss each gas law separately, I would like you all to know what actually is a gas law. There are three important quantities, three important parameters which discuss the behavior of a gas. Which are they? Yes. One, we say pressure on the gas. The other, we say volume. And the third one, we say temperature. So the three physical quantities which explain the behavior of a gas, which explains the nature of a gas, are pressure, volume, and temperature. Any law which is formulated, keep in mind, try to understand, any law which is formulated to explain the behavior of a gas using any of these two quantities, keeping the third one constant, is called as a gas law. ಏನಿದು ಗ್ಯಾಸ್ ಲಾ ಅಂದ್ರೆ ಯಾವುದೇ ಗ್ಯಾಸಿನ ಬಿಹೇವಿಯರ್ನ ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕಾದ್ರೆ, ಅದರ ನೇಚರ್ನ ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕಾದ್ರೆ ನಾವು ಗಮನಿಸುವ ಮೂರು ಕ್ವಾಂಟಿಟಿಗಳು ಯಾವುದು? ಪ್ರೆಷರ್, ವಾಲ್ಯೂಮ್ ಮತ್ತೆ ಟೆಂಪರೇಚರ್. ಹಾಗಿದ್ಮೇಲೆ ಗ್ಯಾಸ್ ಲಾ ಅಂದ್ರೇನು? ಈ ಮೂರು ಕ್ವಾಂಟಿಟಿಗಳಲ್ಲಿ ಯಾವುದಾದ್ರೂ ಎರಡು ಕ್ವಾಂಟಿಟಿನ ಉಪಯೋಗಿಸ್ಕೊಂಡು ಮೂರನೇದನ್ನ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿಟ್ಟು ಒಂದು ಗ್ಯಾಸಿನ ಬಿಹೇವಿಯರ್ನ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದ್ರೆ ಅದನ್ನೇ ಗ್ಯಾಸ್ ಲಾ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಫಾರ್ಮ್ಯುಲೇಟಿಂಗ್ ಅ ಗ್ಯಾಸ್ ಲಾ ಮೀನ್ಸ್ ಯು ಆರ್ ಎಕ್ಸ್ಪ್ಲೇನಿಂಗ್ the behavior, the nature of a gas using any two parameters from here, keeping the third constant. That is what we call as a gas law. And the first gas law that we study is something called as Boyle's law. Boyle's law, formulated by the scientist Graham Boyle. Now, what does Boyle's law say? Let us first understand and concentrate the statement of Boyle's law. Boyle's law says the volume, ನೋಡಿ ಯಾವ ಕ್ವಾಂಟಿಟಿನ ಉಪಯೋಗಿಸ್ಕೊಳ್ತಿದ್ದಾರೆ ಬಾಯ್ಲ್, the volume of a fixed mass of a gas. Volume of a fixed mass of a gas. ವಾಲ್ಯೂಮ್ ಅಂದ್ರೆ ಏನ್ ಮಕ್ಕಳ? ವಾಲ್ಯೂಮ್ is nothing but the space occupied by the molecules of a gas in a container. Some region, molecules ಒಂದು ಕಂಟೈನರ್ ಒಳಗೆ ಎಷ್ಟು ಜಾಗನ, ಸ್ಪೇಸ್ ಅಂತ ಕರಿತೀವಿ, ಆಕ್ರಮಿಸಿಕೊಳ್ಳುತ್ತವೋ ಅದನ್ನೇ ವಾಲ್ಯೂಮ್ ಅನ್ನೋದು. So the volume of a fixed mass of a gas, some mass of a gas, is inversely proportional. Vyatirikta relationship. Volume is inversely proportional to its pressure. ಏನ್ ಪ್ರೆಷರ್ ಅಂದ್ರೆ ಫೋರ್ಸ್, ಸಮ್ ಟೈಪ್ ಆಫ್ ಫೋರ್ಸ್ ಪರ್ ಯೂನಿಟ್ ಏರಿಯಾ. ಸೊ ವಾಲ್ಯೂಮ್ ಇಸ್ ಇನ್ವರ್ಸ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ಪ್ರೆಷರ್, ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ಲಿ ವೆನ್ ಟೆಂಪರೇಚರ್ ರಿಮೇನ್ಸ್ ಕಾನ್ಸ್ಟೆಂಟ್. ನೌ ಸಿ how beautifully Boyle has formulated the law where he is explaining the nature of a gas in terms of its volume and pressure, keeping temperature constant. ಇದನ್ನೇ ನಾನು ಮೊದಲು ಹೇಳಿದ್ದು. ಗ್ಯಾಸ್ ಲಾ ಅಂದ್ರೇನು? ಯಾವುದೇ ಎರಡು ಕ್ವಾಂಟಿಟಿಗಳನ್ನು ಬಳಸ್ಕೊಂಡು ಒಂದು ಗ್ಯಾಸಿನ ನೇಚರ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿ ಮೂರನೇ ಕ್ವಾಂಟಿಟಿನ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿಡ್ತೀವಿ. So he says the volume of a fixed mass of a gas, volume of some certain mass of a gas is inversely proportional. Look at the dependency. It's not directly related. Volume is inversely proportional to the pressure when the temperature of the gas remains constant. Now, how do I understand this statement? I assume a classroom is designed for 50 students to occupy it. ಒಂದು ಕ್ಲಾಸಲ್ಲಿ ಒಂದು 50 ಸ್ಟೂಡೆಂಟ್ಸ್ ಆರಾಮಾಗಿ ಕೂತ್ಕೋಬಹುದು. So the space inside the classroom is sufficient only for 50 students. But what if I accommodate 500 students inside that class? 50 ಜನರನ್ನ ಬಿಟ್ಟು 500 ಜನರನ್ನ ಆಕ್ಯುಪೈ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ? ಆಲ್ ಆಫ್ ಯು ವಿಲ್ ಸ್ಟಾರ್ಟ್ ಫೀಲಿಂಗ್ ದಟ್ ಇರಿಟೇಷನ್. You start feeling that pressure. Why? That space is not sufficient for 500 students, which means ಅಲ್ಲಿ ಸ್ಪೇಸ್ ಅಂದ್ರೆ ವಾಲ್ಯೂಮ್ ಕಮ್ಮಿ ಆಗಿದೆ. ಹಾಗಿರೋದ್ರಿಂದ ಸ್ಟೂಡೆಂಟ್ಸ್ ಮೇಲೆ ಪ್ರೆಷರ್ ಜಾಸ್ತಿ ಆಗ್ತಿದೆ. ಎಲ್ಲರೂ ಜಾಮ್ ಪ್ಯಾಕ್ ಆಗಿ ಕೂತ್ಬಿಟ್ಟಿರ್ತಾರೆ. ಯಾಕೆ? 500 ಜನರಿಗೆ ಜಾಗ ಸಾಕಾಗ್ತಿಲ್ಲ. Whereas instead of 50 students, if I occupy only 5 students, all of them are comfortable, no irritation at all, pressure is minimum. Why? Volume is exceedingly sufficient for 10 students, which means since volume has increased, pressure has gone down. That is what Mr. Boyle is trying to define with respect to a gas. He says the volume of a fixed mass of a gas is inversely proportional to its pressure when temperature remains constant. What happens if temperature changes? Little next I jump. So please to understand, this statement holds good. The criterion volume becoming inversely proportional to pressure holds good when temperature remains constant. Now, let V be the volume of a gas at pressure P when temperature remains constant. So therefore we say volume is inversely proportional to pressure. Under what condition? Very clearly, temperature has to be constant. So volume increases, pressure decreases. Volume decreases, pressure increases. So you have to clearly know there is an inverse relation. They are not directly related, inverse relation. And using this, we write PV, product of pressure and volume is constant when temperature remains constant. P into V is a constant. And this is Boyle's equation. PV is constant. Therefore, if I plot a graph of pressure versus volume depicting Boyle's law, when the volume is 0, minimum anta artha, pressure is maximum, inverse relation alva. As volume is increasing, pressure slowly goes on decreasing. So the relation between pressure and volume according to Boyle's law is depicted by an exponential curve. Whereas it is 1 by V versus P. V alla 1 by V. It is a straight line starting from the origin. So these are the features of Boyle's law. Now, coming to the second law, which is Charles' law. Iga Boyle's law kaltvi. Ali, pressure is inversely related to volume provided temperature remains constant ಅಂತ ಹೇಳಿದ್ರು. Now let us understand what does Charles' law state. According to Charles' law, again, the volume of a given mass of a gas, again, beautifully, he is talking about volume. Volume of a given mass of a gas now is directly proportional. See, very beautiful. It is directly proportional to absolute temperature. Given pressure remains constant. Now understand, Mr. Charles is explaining the nature of a gas, behavior of a gas in terms of volume and temperature, and he sees that pressure remains constant here. So very clearly he says the volume of a given mass of a gas is directly proportional to absolute temperature provided pressure remains constant. Now, how do I understand this? There is a container which is initially containing molecules until this space. Therefore, I say initial volume. Some heat is supplied. This is the volume occupied by the molecules. This is the initial volume. Now more heat is supplied. Previously we have to understand, or we have understood, as heat is supplied, heat is increased, temperature of the system increases. Remove heat from a system, temperature decreases. ಒಂದೊಂದ್ಸತಿ ಐಸ್ ಮೇಲೆ ಕೂತ್ಕೊಂಡಾಗ ಚೆನ್ನಾಗಿರುತ್ತೆ, ಬೆಂಕಿ ಮೇಲೆ ಕೂತ್ಕೊಂಡು ನೋಡಿ, ಬಿಸಿ ಆಗಿರೋದ್ರ ಮೇಲೆ ಕೂತ್ಕೊಂಡು ನೋಡಿ, ಎಂಥ ಪ್ಲೆಷರ್ ಅಲ್ವಾ? So now increase the supply of heat to the system, temperature increases. So that is what I have shown as T plus delta T. Delta T is the increase in temperature. When the temperature increases, in the third chapter you understand, you are supplying energy to these molecules. The kinetic energy of the molecules increases as there is an increase in temperature. Energy ಜಾಸ್ತಿ ಆಗಿದೆ, molecules to ಕೊಬ್ಬು ಜಾಸ್ತಿ ಆಗಿದೆ, ಗೂಳಿಗಳಾಗಿವೆ. So what will they do? They will just start occupying more volume. ಸೈನಿಕರ ಶಕ್ತಿ ಜಾಸ್ತಿ ಆಯಿತು, ತುಂಬಾ ರಾಜ್ಯಗಳನ್ನ ಯುದ್ಧಗಳನ್ನ ಗೆಲ್ಲಕ್ಕೆ ಶುರು ಮಾಡಿದ್ವು. Similarly here, you have increased the temperature. So doing, kinetic energy of the molecules has increased. It has started winning more space inside the container. Molecules are occupying more volume. And this happens when pressure on the molecules remains constant. No extra force. Yake? Quite amount of kinetic energy is supplied. So very clearly you see the volume occupied by the gas molecules increases proportionately, directly, as the absolute temperature increases, provided I keep my pressure constant. So very clearly, the volume of the given mass of a gas is directly proportional to absolute temperature when pressure remains constant. Therefore, we write the equation V is proportional to T only when pressure remains constant. But my dear students, people went for an experimental justification, experimental verification of Charles' law. An experiment was conducted, and based on the data of that experiment, a graph was plotted where temperature was along x-axis, volume was along y-axis. So according to the statement, what should be the nature of the graph? Volume is directly proportional to temperature. So it has to be a straight line passing through the origin. Alva? Temperature ಜಾಸ್ತಿ ಆಗ್ತಿದ್ದಂಗೆ volume ಜಾಸ್ತಿ ಆಗಬೇಕು. But for their astonishment, at lower temperature, the graph was a solid curve. Lower temperatures ಅಲ್ಲಿ ಸ್ಟ್ರೇಟ್ ಲೈನ್ ಸಿಕ್ಕಲಿಲ್ಲ ಅವ್ರಿಗೆ. ಡೈರೆಕ್ಟ್ ರಿಲೇಷನ್ ಬಿಟ್ವೀನ್ ವಾಲ್ಯೂಮ್ ಅಂಡ್ ಟೆಂಪರೇಚರ್ ಸಿಕ್ಕಲಿಲ್ಲ. ಅಲ್ಲೊಂದು ಸಾಲಿಡ್ ಕರ್ವ್ ಸಿಕ್ಬಿಡ್ತು. And a curve became a straight line only at higher temperatures. Andre, they proved that Charles' law is valid only at higher temperatures. There was a classical failure of Charles' law at lower temperatures. So my dear students, we can see one limitation of Charles' law here, one flaw, drawback of Charles' law. Adenadu drawback. ಚಾರ್ಲ್ಸ್ ಲಾ ವ್ಯಾಲಿಡ್ ಆಗೋದು ಹೈಯರ್ ಟೆಂಪರೇಚರ್ಸ್ ಮಾತ್ರ. At lower temperature, a classical failure happens. Now, continuing my discussion, here comes a very important concept, something called an ideal gas. Now, what is an ideal gas? ಏನ್ ಐಡಿಯಲ್ ಅಂದ್ರೆ ಎಲ್ಲಾ ರೀತಿಗಳಲ್ಲೂ ಪರ್ಫೆಕ್ಟ್ ಆಗಿರೋದು, ಒಂದೇ ಒಂದು ಲಿಮಿಟೇಷನ್ ಇರಬಾರ್ದು, ಒಂದೇ ಒಂದು ಡ್ರಾಬ್ಯಾಕ್ ಇರಬಾರ್ದು. ಸೊ ಐಡಿಯಲ್ ಗ್ಯಾಸ್ ನಾವು ಪರ್ಫೆಕ್ಟ್ ಗ್ಯಾಸ್ ಅಂತ ಕರಿತೀವಿ. ಇಟ್ ಹ್ಯಾಸ್ ಟು ಬಿ ಪರ್ಫೆಕ್ಟ್ ವಾಟ್ ಎವರ್ ಮೇ ಬಿ ದಿ ಸಿಚುವೇಶನ್. ದ ಡೆಫಿನೇಷನ್ ಸೇಸ್ a gas which obeys Boyle's law and Charles' law. ಯಾವುದೇ ಒಂದು ಗ್ಯಾಸ್ ಮಿಸ್ಟರ್ ಬಾಯ್ಲ್ ಅಂಡ್ ಮಿಸ್ಟರ್ ಚಾರ್ಲ್ಸ್ಗೆ ನಿಷ್ಠಾವಂತರಾಗಿದ್ರೆ ಅದನ್ನೇ ಐಡಿಯಲ್ ಗ್ಯಾಸ್ ಅಂತ ಕರೆಯೋದು, ಅಥವಾ ಪರ್ಫೆಕ್ಟ್ ಗ್ಯಾಸ್ ಅಂತ ಕರಿತೀವಿ. So any gas which obeys or which is valid to both Boyle's law and Charles' law is an ideal gas or a perfect gas. Adre, this is a very elementary definition. Tumba skeletal agoytu. 7th ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಅಲ್ಲಿ ಹೇಳ್ತಾರೆ ಏನ್ ಐಡಿಯಲ್ ಗ್ಯಾಸ್ ಅಂದ್ರೆ ಅದು ಚಾರ್ಲ್ಸ್ ಲಾನು ಒಬೆ ಮಾಡಬೇಕು, ಬಾಯ್ಲ್ಸ್ ಲಾನು ಒಬೆ ಮಾಡಬೇಕು. ನೌ aggravating our thoughts, let us try to understand the superior characteristic of an ideal gas. The first characteristic says ideal ಆಗಿರ್ಬೇಕಲ್ವಾ, intermolecular force of attraction should be zero. Molecules, ideal students, ತನ್ನಿದ್ದಲ್ಲೇ ಇರ್ತವೆ, ಪಕ್ಕದವ್ರನ್ನ ಡಿಸ್ಟರ್ಬೇ ಮಾಡಲ್ಲ. ಅದೇ ರೀತಿ ಐಡಿಯಲ್ ಗ್ಯಾಸ್, ದ ಮಾಲಿಕ್ಯೂಲ್ಸ್ should show zero intermolecular attraction. There should be no interaction between the molecules of an ideal gas. So the first nature of the ideal gas is the intermolecular force between the molecules of that gas should be zero. And the second nature is pressure exerted on the molecules of this gas should be zero. Only when the gas attains these two features, we attribute it, we call it to be an ideal gas. Yaudadu first? Intermolecular force of attraction should be zero. Here there should be no force of attraction between the molecules. Pressure exerted on the molecules should be zero. Now if P is the pressure, T is the temperature, V is the volume, ideal gas equation is written as PV equals RT. This is called the ideal gas equation. P is the pressure, V is the volume, R is a constant called universal gas constant, T is absolute temperature. But my dear students, the practical question is, Can such an ideal gas exist in nature? ಒಂದು ಕ್ಲಾಸ್ ಅಂದಮೇಲೆ 100 ಸ್ಟೂಡೆಂಟ್ಸ್ ಇದ್ರೆ 100 ಸ್ಟೂಡೆಂಟ್ಸು ಫಿಸಿಕ್ಸಲ್ಲಿ 100 ಸ್ಕೋರ್ ಮಾಡ್ತಾರಾ? 100% ಕಾನ್ಸಂಟ್ರೇಷನ್ ಇರುತ್ತಾ? 100% ಡಿಸಿಪ್ಲಿನ್ ಇರುತ್ತಾ? ಕಷ್ಟ. So these two factors can never be attained. If there is a gas, if there is a system, if there is molecules, they will interact. Maybe the interaction may be minimum, but you cannot say zero. There will be some pressure acting on them. Therefore, the physical existence of an ideal gas is not possible. And all gases which exist now are called real gases. You don't have anything called as an ideal gas. This feature cannot be attained. So, the gases which exist, they are real gases. They tend to behave as an ideal gas. Okay? Now, here is an assignment for you all. I want you to just refer your textbook and go through triple point of water. Interesting concept, but an assignment. So students, I have discussed the important gas laws in my session. Beautifully, the formation of Boyle's law and Charles' law, and then covered something called as an ideal gas. Don't forget the assignment. In my next session, we will attribute the properties of heat to matter. Until then, stay safe, enjoy. Thank you.